Okay, let's talk about an invisible force that, believe it or not, powers pretty much everything around you. I mean, from the doorbell you press every day to these giant machines that can lift entire cars. It's this amazing, invisible connection that totally changed the game for all of us.
So, where did this all begin? Well, to really get it, we have to travel back in time a bit and look at a huge question that scientists were wrestling with for centuries. You see, for the longest time, everyone thought electricity and magnetism were two completely different things. Like they were totally separate, almost magical forces. On one hand, you had the crackle of lightning, and on the other, the quiet, mysterious pull of a magnet. But then some really smart people started to think, wait a minute, is this just a coincidence? Or is there some kind of secret connection between a spark of electricity and the pull of a magnet?
And the answer, it turns out, was a massive yes. That discovery basically kicked off a whole new branch of science called electromagnetism. And here's the core idea. When an electric current flows, it doesn't just move from point A to point B. It actually creates a magnetic field all around it. So yeah, they're not separate forces at all. They're more like two sides of the same incredible coin.
Now, this amazing idea isn't just some abstract thing you'd find in a textbook. Nope. It led to the invention of a device that is, and I'm not exaggerating, the workhorse of our modern world. The electromagnet.
So what is it? Well, at its core, an electromagnet is super simple. It's just an object that turns into a magnet when you run electricity through it. That's it. It's a temporary magnet that you can switch on with an electric current.
And right there, that's its superpower. Think about your average fridge magnet. It's always magnetic, right? It's always on. But an electromagnet, you can turn it on and off just by flicking a switch. And that simple ability to control it, well, that's what makes it one of the most useful inventions ever.
Okay, so how does this magic trick actually work? The best way to get it is to just build one. Not for real, but in our heads. And you'll see just how simple the parts are.
All it takes is 3 basic steps. First, grab an iron nail. That's going to be our core. Second, you wrap a wire tightly around it, making a coil. By the way, the more loops you make, the stronger the magnet will be. And finally, you just connect the 2 ends of that wire to a battery, and that's it. You've just made a simple circuit. So the second you connect that wire, boom! Electricity starts flowing from the battery, zipping through that coil, and it creates a magnetic field all around the nail. And if you bring a few paper clips or pins close to it, they'll snap right onto it. It's like you've created a magnet out of thin air. But here's the really cool part. The second you disconnect that wire from the battery, the electricity stops flowing. And just like that, the magnetic field completely disappears. Poof! And all those pins just drop. On, off. It's really that simple, and that's what makes it so powerful. Okay, so we've made a little magnet that can pick up some pins. That's neat. But what if we want to lift something bigger? A lot bigger. Like, say, a car. How do we take this simple idea and totally level it up? Now that is the big question for engineers, right? Because if you can control how strong the magnet is, you can use it for all sorts of amazing things. And luckily, there are a few simple ways to crank up the power.
There are basically 3 main dials you can turn. First, you can add way more coils of wire around that nail. More coils means more magnetic power. Simple. Second, you can pump more electricity through it. Use a stronger battery. More juice in means more magnetic force out. And finally, the type of core you use really matters. Some materials, like iron, are fantastic at focusing that magnetic field and making it super strong.
So we've got this magnet that we can turn on and off, and we can even make it stronger or weaker. Super cool piece of physics, right? But where do we actually use this thing? Well, the answer is pretty much everywhere.
If there's one thing to remember, it's this. Electromagnets are like the ultimate energy converters. They take electrical energy, which is super easy to make and send down a wire, and they turn it into actual physical movement. Pushing, pulling, lifting, spinning, you name it. This one idea is the bedrock for so much of our technology.
Let's start right at your front door. You press the doorbell button, right? Well, when you do that, you're completing a circuit. That powers up a tiny electromagnet inside, which pulls a little metal hammer, and that hammer strikes a bell. Ding dong! Yep, that's an electromagnet at work.
Okay, now let's go from that tiny doorbell to something huge. Picture a scrapyard. They have these massive cranes with a giant metal disc on the end. That's an electromagnet. They lower it down over a pile of cars, crank up the electricity, and bam, it lifts tons and tons of metal. Then they just swing it over, cut the power, and it drops the whole load exactly where they want it.
And what about anything that spins using electricity? Your fan, a blender, an electric car. What do they all have in common? An electric motor. And what's at the heart of an electric motor? You guessed it. A bunch of electromagnets turning on and off in a perfect rapid-fire sequence to create that constant spinning motion. It's just motion from electricity, pure and simple.
And it doesn't stop there. The applications get even more mind-blowing, especially when you look at modern medicine. You know those MRI machines in hospitals? They use incredibly powerful, super-cooled electromagnets to see inside the human body, creating these detailed images that help doctors find problems without ever having to make a single cut.
So think about that. From a simple nail wrapped in wire to a machine that can save lives, the basic idea is exactly the same, using electricity to create a magnetic force that we can control. This invisible force is, without a doubt, one of the pillars of our world, just quietly doing its job all around us. Which really just leaves one big question. What are we going to power with it next?